I'm Ondřej, and now I work for ISC for a year and a half, trying to make Bind better. So, quick show of hands, who uses Bind here? And who loves Bind? Who hates Bind? And who has love-hate relationship? Okay, so, when I joined ISC, I thought this is like a good opportunity to work on something really old, because Bind was first released in the year 2000. It was written from scratch. It used something called design by contract, which basically means that instead of having a buffer override that would lead to execution of the code on the stack, it crashes. So pick your poison, but I think that the decision was good to make Bind crash rather to have yet another remote vulnerability. It was also the first DNSSEC implementation in a DNS server. By the time Bind 9 was designed with DNSSEC in mind. Of course, it was the DNSSEC before the current DNSSEC, so it had to be rewritten anyway. So let's move to more current time. So Bind 9.11 ESV, the ESV means extended support version, which basically means if the release is marked as ESV, it will be supported for at least 4 years. For people who don't like to upgrade working stuff. It was also the first Bind release under Mozilla public license. ISC changed license from the ISC license, which was very permissive, to a Mozilla public license, which is per file based. And it featured stuff like to ease management of zones, like catalog zones. You can now add zone, deal zone with RNDC command. It has a DNSSEC key manager, which helps with rotating the keys. It added support for negative trust anchors if somebody forgets to reassign the zone, so it doesn't stop working. That's important for operators of the resolvers. It supports DNS tab for tapping on what's going on the wire. DNS cookies, which is an important mechanism against DDoS attacks. And if you want to make your traffic smaller, you can enable minimal responses to any queries. So that was in 2016. Last year, in the I think February, we released Bind 9.12 that also had the new features. NSEC aggressive use. What it means is that if the zone is signed, DNSSEC signed, and you receive a response that the domain doesn't exist, it can use the whole range which NSEC covers to answer from a cache. So it reduces the number of the queries that goes to the upstream servers. As a reaction to recent attacks on DNS, there's a support for serve-stale, which basically what it does is when the upstream servers are unreachable and you still have the entry in a cache, you stretch a TTL a little bit until the servers are reachable again. So that helps if the provider is under attack and all the servers are unreachable. So it helps with users to get the correct answer. Then one of the major things that has been done. There has been major refactoring in the query find, the most important function that was really long, so it was split into small pieces. And there's a good presentation on that from 2 years ago by Evan Hunt, my colleague at the DNS.org. And there was also a speed up factor, which was quite significant in some scenarios. And again, some DNSSEC improvements, new algorithm support, and it was obsoleted by Bind 9.14, so it will now only receive the security updates for a couple of months, and then you should upgrade to, if you are using Bind 9.12 to Bind 9.14, which was released 2 weeks ago. It's still a baby. It goes under new release schedule. We prepared. I will tell you about that more later. Again, we did a lot of refactoring and modernization of the code, and also added the new features. It features the Kuna minimization. I'll tell you what it is later, and mirror zones, and we now can have plugins that, like internal and external plugins that can like modify the query response processing. So, well, for the modernization part, well, I told you already that Bind comes from year 2000, where there were a lot more diversity in the Unix and Unix-like systems, which doesn't exist anymore. So we removed a lot of like workarounds for all the broken systems. So if you are hiding that SGI under your desk and you still think that it could run modern bind and modern DNS, then at least upgrade your compiler to support C99. Bind now also requires POSIX threads, advanced socket IPI for IPv6, and standard atomics, but we do have some workarounds, so it works even with the older GCC that has built-in atomics. So that would be GCC 4.8. So if you can upgrade at least to GCC 4.8, it will still work. But yeah, we dropped support for a lot of old systems that doesn't exist anymore, and that's the reason is because we don't have those systems. We are not able to provide any assurance that it works at all. So and it's actually better to just upgrade hardware. The other thing we did for the release was the crypto refactoring, the PKCS11, which is the interface to communicate to hardware, the HSMs. So the hardware box that keeps your key secret. So the PKCS11 was used, or was intended to be used for all cryptographic operations, even though many of the HSMs and the libraries didn't support the algorithms. So there was, again, a lot of workarounds and testing, and you have to compile bind for a specific HSM. So that's mostly solved now, because the PKCS11 is now only used for public key cryptography, which means to keep your DNS keys secure, but all other operations are like random number generation and hashing and HMAC for TSIG is now performed by OpenSSL, so which means OpenSSL is now mandatory. We also did some performance improvements, which allowed us to increase the performance by 100K or more. Again, it depends on the scenario, and that's because of the refactoring we did. So the task manager, that you receive a packet from a network, and before there was just one thread that just handled all the connections, and it just like multiplexed it to other threads. So that's now, it runs multiple threads. So when you are listening on the interface, it can process the packets more faster, and it allowed us like, this is the bind. Sorry, this is bind 9.11, this is 9.12, and the last is 9.14. It was somewhere in the picture, but it disappeared. I'm sorry for that. But it goes right and up, so it must be good graph. Kuna minimization. Who does know what Kuna minimization is? Okay, a couple of hands. So it's an internet standard. It improves DNS privacy. So the information in DNS aren't really private, right? Because you can query them from outside. But it doesn't mean that the transactions doesn't have to be private. So the change to the resolving, and I'll show you this in more detail, is that the resolver now sends only minimal info it needs to each authoritative server, so it doesn't leak the information that much. And it has been enabled by default in relax mode in bind 9.14. The relax, there are like 3 options: off, relax, and strict. So in relaxed mode, if something like bad happens on a wire, it falls back to the old mechanism and tries to give you the answer. So the normal DNS traffic goes like, here you have stub resolver, here you have the resolver, which would be bind in this case. And if you ask for www.isc.org, it will go to the root zone system and ask for www.isc.org quad A, and it goes at every level, and it leaks the whole information about the query, the original query. So that's how it works right now. So the Kuna minimization changes that in a way that if the stub resolver, it means your computer, ask for www.isc.org, it goes to the resolver, and the resolver just leaks the sends the minimum query. So it asks what are the name servers for .org, and the root system answers that, and then it goes, it adds a level and it asks what are the name servers for isc.org, and it asks the org name server, and only then finally it goes and asks www.isc.org to the isc.org servers. So that at every level only the minimum possible information is sent to the upstream authoritative server. So it doesn't leak so much information. So it is a protection against all kind of like passive listeners on the wire. Of course, it doesn't really help if you have somebody listening right just behind your resolver here. So, but if you if people are collecting data on the root servers, org servers, it helps with that because it leaks less information. So, root zone local copy, that's another feature I did in Bind 9.14. This was work funded by ICANN, and there's again RFC, so it's internal standard. And what it is meant for, it reduces the traffic to the root zone system. So the configuration in Bind and any other resolver that has the support for this, which might be, like the implementations might differ, but basically what it does, it transfers the root zone locally inside the Bind, and then DNSSEC validates it if like it wasn't mangled in transport and it's still valid. And the root zone is only used internally. You can't query it directly. It will always go through the resolver. But it will be used locally for some time, then it will be retried. The bind will retry to download it again, and the cycle goes on and on. But basically, this reduce all the traffic that would go to the root zone to just one transfer per 12 hours, because that's basically how the root zone is updated. So this is improvement for the resilience and stability of the internet. So that's the Bind 9.14. So what are our plans for 9.15? I'm sorry, this is stock image from Keynote. I'm sure you know it if you have Mac. Somehow I forgot to change it, but it fits quite well. We love our Bind. So there are 4 areas we want to focus, and that's performance again, because as you might know, Bind is kind of underdog right now compared to other DNS servers, and we want to put it back into the first league, so you don't have to worry about the performance. The other areas is management, then security and privacy, and helping with the operations. So performance. Basically, the goal is not to be first, have the highest number of the queries per second. From some point, it doesn't matter. Would you really care if the performance would be 1.5 million or 1,600,000? I don't think so. So when you get to a point that the performance is enough, I think you can stop optimizing, because Bind has other advantages, because it's much more flexible but we are not there. And we want to get there. So you don't have to care about the performance of Bind. So the big thing planned for this year is the whole networking stack will be rewritten and re-engineered, and changing the intranets. So that's the thing that's not really visible on outside, because it's not a new feature. The goal is that the Bind will perform familiar to you. So nothing will really change, but it will be simpler and it will be much faster. So it should improve both UDP and TCP in performance. And so far, the plan is to use a library called libuv, which is used in other projects. And it's a fully asynchronous library with the even loops, and it can use all the modern networking I/O that's available on the platform. So it basically shields the end application from the specific implementation specifics for the platform. So it can use ePOL, it can use KQ on FreeBSD, it can use IOCP on Windows. But for the application, the interface is still the same. So it helps simplify the code. It has asynchronous TCP and UDP sockets and more stuff like thread pool, signal handling, high resolution clock. The library is really good, and I think it will help Bind to be more simpler because it won't have to care about all the stuff. So we would be able to focus on DNS again, not about it, like, will it work here? How fast it will work? Because that will be handled by libuv. So for the management, actually this is an area where we would really like to get a feedback from you users, and that's the metrics and statistics we generate, because Bind has a really too many counters, but we actually don't know what's useful because we don't get much feedback on that. So if you are missing a counter, if you think there are too many counters, please tell us. So that's one of the areas we want to focus on this year and change, maybe remove some counters that doesn't make any sense because they are used only internally. I don't know. There are counters for how the memory pools inside Bind are used. I don't think that users care about that stuff, you know. So we would like to hear from the users what's missing or what's extra and could be removed. The other stuff is the updated catalog zones, because there's been update to the RFC, and we need to align the two. If you don't know what the catalog zones is, which you might not, it's like meta zone that contains the other zone, so it's for easier provisioning. So if you have two binds talking to each other, you can have a catalog zone and it will synchronize the list of the zones between the two. The other stuff, that basically the DNS over TLS, again, DNS privacy, so we don't leak metadata. You currently don't know what's in the letter, but it kind of leaks the metadata here. So DNS over TLS hides the DNS traffic into TLS transport. It's defined in these two RFCs. It's running on a different port 853, and this will be really the next transport we could add on top of the new networking code. So it will be also good for us that we will know that if there's something like DNS over quick in the future, we'll be able to add it in a simple manner instead of against hacking it together. So we will have something. The networking stack will be built on the libuv, and this will be a module into that will add another transport. So what needs to be added? Supporting clients, so you can debug it, because the dig and delve and the other tools that talks DNS are usually used to debug DNS, and so you need the support there. We should probably add it to named when acting as a forwarder, so it can talk to the upstream servers, to upstream forwarders with DNS over TLS. And also in server, so Bind can act as a client and as a server. So the other thing that recently emerged from IETF is the DNS over HTTP, DOE. I have mixed feelings about this because it mixes traffic with HTTPS. So it's much harder to control your networks, because then the browser can connect to big CDN and mix real HTTP traffic with the DNS traffic inside, and unless you are wiretapping the TLS, which is a bad thing on itself, you have no way how to control this, because it's hidden in the HTTPS traffic. That said, I strongly believe that we should not allow these big companies concentrate all the traffic to themselves. I don't have like anything personally against Google, Cloudflare, or other big companies that has the Quad A, Quad 1, Quad 9, the resolvers. There's nothing personal in that. But I think we should offer an alternative for the people that don't want to use it. But the browser guys are sort of, especially Mozilla, is pushing for this to happen. So I think that it's important that the open source DNS vendors also provide alternatives. So you can run your own DNS over HTTPS server locally, and you have control over your DNS, because that's what it is about, to have a control. I know that, again, the claim is that it's improved privacy of the users, but it also prevents controlling the DNS traffic, and it's important in some scenarios. You want to prevent malware, maybe you have children at home and you want to apply filters, so what they can see and what they shouldn't see, or what they shouldn't post on the internet. So, keeping the control of your own network is important in some cases. One of the way how we could do that, the most probable way is that we will write a proxy module for Apache and Nginx, and other support for a proxy protocol in Bind. So it will be universal thing that could be deployed with any of the DNS servers. The last part that I think needs improvement, as I already told you, the Bind was the first to implement DNSSEC, and we gained a lot of experience since then. So I think there's a presentation on ISC website called DNSSEC in 6 minutes, and I strongly believe that the 6 minutes are too much. I think that DNSSEC should be enabled by simple yes, sign this, and make this magic happen with your registrar. So it will pick reasonable defaults for the keys. It will try to automate everything: key creation, key rotation, child-to-parent communication using the CDS, CDNS key records, if the registry supports that, the periodic signing. So all you would have to do is to say, yes, I want this DNSSEC. I don't know what it is, but it seems nice, so please buy and do it for me. And also improvement in some more niche areas like offline cascades, maybe stored in the HSMs, or combined signing keys to reduce the answers, so you have just one key. And that's possible because the rotation will be easy with the CDNS key, CDS protocol. The next thing this is not about the code, but it's about, I think that the conversion did something to the table here. Or maybe when I stretch the slides. Again, this is a timetable on the top. This is the release schedule I talk about. So we do have a stable releases, that would be 9.14. We have a development releases, that's the odd numbers. And then there are extended support versions. So every 2 years, we will release the extended support version that we will keep supporting for at least 4 years. The next one would be 9.16. We are changing the schedule, so it's a little bit different than it will be in the future. So 9.16 would be extended support version, 9.12 will be an extended support version, and 9.16 will be released next year, 2020. What we are also changing from 9.14 and 9.15, that we would like to do time-based releases. So the current plan is that it will be the third Wednesday in a month. So the third Wednesday on the month, there will be at most release. So if there's not enough, stuff in in between, we will probably not do the release, but we will not do them outside of this window. So if you are maintaining your network, you will know, hey, it's a time that there might be a new bind release that I want to upgrade because there might be a security update. So this means it will be more predictable, and it will be easier to work it into your plans. How do you manage your network? So that's all from me, and now I'm ready to take questions if you have any.
Any questions for Ondřej? Sorry, can you wait for the mic? And thanks.
Hi, Anders living here, Abundo. Do you have any plans for adding any SQL support, for example, as backing store?
There are right now there are 3 different ways how to add more stuff into Bind, and that DLZ, that's the old interface. And there's a new one written by Red Hat DynDB, which you can use to write a new database support if you want to the zone stored differently. And I expect that in a time they will converge into one plugin interface, so you will be able to add a new module that will handle the configuration. They will handle the database, they will handle the zones, they will handle the cache. So this is really long-term plan for Bind, but since we have the plugin interface now, we want to chop off the pieces of Bind into separate modules that will be still maintained by us. But so the core of the Bind stays really slim and thin, and it could be easily refactored. But it will also allow people to contribute more modules that will do some stuff they need. And did that answer your question?
Thank you.
Another question for Ondřej. Okay. Well, please join me in thanking Ondřej for his presentation. Thank you.
Thank you.